Good morning, everybody. So I am Jean-Marc Lambert, a consultant specialized in the application delivery and container platforms at SUSE. Today I will introduce how SUSE Cloud Application Platform can reduce your lock-in to cloud vendors and open you to the hybrid and multi-cloud era. So in terms of agenda, we will first introduce SUSE CAP in the SUSE ecosystem. We will explain the typical SUSE CAP deployment and introduce service broker concept and respond to some questions that are triggered by the multi-cloud perspective. We will also explain how Stratos, that is the UI for Cloud Foundry, federates this approach as a unified multi-cloud platform. We explain how Stratos federates this approach as a unified multi-cloud console. So first, Cloud Application Platform is the PaaS offering of SUSE. It leverages SUSE technology to provide a seamless cloud-native application development and delivery frameworks based on the Cloud Foundry ecosystem. I will not present CAP itself here, as many other sessions elaborate it. In the SUSE offer, we can mention that the SUSE CAP platform can be deployed easily to provide the same experience for dev and ops on any public cloud running a Kubernetes cluster or on a SUSE CAS platform, that is the way you can deploy a Kubernetes cluster on-premise. The SUSE Global Services can accompany you on this application transformation journey. Now let's enter the actual cloud application development architecture. So first we have the SUSE CAP that implements the Cloud Foundry features. It is consumed by dev and ops via the CF API and the CF CLI, that is the common language interface at the console level, or through the web UI called Stratos. You can easily construct microservices on this platform using these tools. In aim to connect your platforms to the internet, you need also another set of components. The ingress controller to connect your internal Kubernetes service to outside world, a public DNS and a load balancer to make your application accessible from internet. If you need some HTTPS connections, you will need to introduce a Let's Encrypt or another type of certificate manager. Then we'll have a last point, that is the service broker, that provides on-demand services like databases and manage their connection from your app. Let's elaborate around service brokers. So the service broker is situated in between the SUSE CAP Cloud Application Platform and the cloud service provider. It is a way to allow the application developer or the dev operation team to request and get some provisioning of new services to consume by the application. So this service broker exposes a catalog of services, and these services are available through a standard API called Open Service Broker. The application platform itself integrates this API and can integrate many service brokers, as we have many cloud service provider or equivalent service broker offering. The service broker helps in the managing of a full life cycle of a service, like the creation, the deletion. On a service creation, the service broker returns some kind of connection credentials to reach it. Cloud Foundry application will bind this service to the requested application using these credentials. So an example of a service broker, this one is the Amazon Web Services Service Broker. So this one is provided by Amazon, but can be deployed on any Kubernetes platform, and it's located in between the CAP and the various services that are available to Amazon. So now let's have a look to the portability of SUSE Cloud Application Platform. So in fact, to deploy this SUSE Cloud Application Platform, that we will synthesize CAP, In fact, we need just a Kubernetes cluster. This Kubernetes cluster can be either provided by one of your public cloud providers like EKS, AKS, GKE, or on any of them you can deploy on your own a SUSE CAS Platform version 4 to have a unified Kubernetes layer on the top. The cap after can be deployed to any of them in an identical way. So this deployment is performed using Helm. It is the standard deployment and configuration tool for Kubernetes. As mentioned, we have introduced already the service brokers. And what is interesting is that we have many service brokers that are provided by many cloud providers to make their services consumable by application. So we have some service broker from Amazon, from Azure, from Google, but as well, if you need, you may develop or get some over from various software vendors, some customized service broker to leverage your existing or other type of services. So with that, you have a very huge number of services available from your CAP platform. Another element that is important is you can deploy the CAP platform on various clouds, but you may have as well many instances of this CAP if you want to leverage various services or to make some distributed type of deployment. In aim to have a unified experience from the UI side, the SUSE Stratos console is able to connect to many CAP instances and provided the unification of visualization for any application running in any of these instances of CAP. As well, inside this Stratos, you can visualize the services, the catalogs, or anything from the Kubernetes side. So with the SUSE Cloud Application Platform, you have no lock-in. We have seen that the SUSE CAP is portable, meaning that you can deploy it on any Kubernetes, and that Stratos and Service Broker are as well portable and can be deployed to any cluster. Don't use a cloud, use the best mix on them on purpose. With the SUSE CAP, applications are also portable. So if you develop an application in one CAP, this application can be easily deployed to another CAP instance on any other type of CAP instance. It can be on any other cloud. Okay. Here as well, you see that the applications are portable from CAP implementation to another. It can as well, for sure, leverage other competition Cloud Foundry frameworks. Here again, the application have no lock-in. Another direction in the lock-in is the languages. The CAP implements an efficient and cost-effective platform for your developments and for your production workloads. Thanks to the long Cloud Foundry experience, many build packs exist for many languages, and these build packs help in automating the building and deployment of your apps in various languages with a similar experience. These languages are available on any cloud and in an identical way, as in fact everything is bundled inside your CAP deployment. Here again, you have no lock-in, as you can let your developers choose their language of preference and have the same development and operation experience whatever the cloud. With your team becoming more DevOps oriented and leveraging automation, with a CAP deployed on many clouds, your DevOps pipelines are able to deploy on many CAP instances in a row. You may choose to have several microservices deployed in one cloud to leverage some service provider specific services, or have your various environments spread among these clouds. Your DevOps pipeline will target the various environments just by one interface, the CF-CLI, that will be attached to the right API endpoint. With SUSE CAP, you see again that there is no lock-in. This application can be spread in multiple clusters. Service brokers can be deployed, we said, on whatever Kubernetes cluster. You just need to configure some credential to reach the cloud provider API and obviously to open network flows to let your application connect the provision services. Here we see one CAP instance deployed in Azure that can consume services through the various brokers, can be AWS, Azure, Google, or even custom service broker developed to encapsulate your own set of service. And your application can seamlessly use and consume any service provided by any of these brokers. With SUSE CAP, you are free to choose the services you need from whatever cloud offering. Again, no lock-in. Let's now study how to manage multi-cloud deployment. In the first point, you need to have, for example, a singleized routing mechanism or DNS mechanism. And what here we can use an example is the Route 53 from AWS. That is a DNS service. And this DNS service can be shared among various deployments. It can be some AKS or EKS load balancers that could be directly routed through the same DNS. Okay. You will use all these entries in the deployment of your CAP solution in the configuration of the M-chart deployment to use the same URLs for connecting to any of your services independently of the CAP instance they run on. Okay, after, for sure, you have done this deployment, you can check the flows and test it through the CF APIs. As said, Stratos, that is the console provided by SUSE, can be deployed on the Kubernetes cluster you choose. Stratos is a multi-cloud GUI for Cloud Foundry, but also for Kubernetes and the service catalog. In Stratos, you will add SUSE CAP API points, the Kubernetes API endpoints, and the metrics endpoints for monitoring. You will also feed it with a set of credentials required to access these various APIs. Developer or ops will see the full set of platforms, if you have connected many, applications and services in a single pane of glass. Within your DevOps pipeline or from the dev station, your CF CLI will be able to push application to any SUSE CAP instance. You may have as well local routes to identify apps from one cluster to another. The user authentication and authorization within CAP is managed by a component called UAA. This component can be deployed once and shared across many SUSE CAP instances. UAA endpoint is configurable in the CAP M-chart deployment and can be shared among multiple CAP deployments. In aim to allow the right routing of your apps to, on incoming traffic, we describe that the need of DNS is mandatory. You will have as well to point the various CF router IP addresses. Oh, sorry. So in aim to allow the right routing of your apps on incoming traffic, we described the need for DNS, so you will have to point the various CF routers IP address to this DNS. In Cloud Foundry, the external routes will be added to the local routes to permit the L7 routing in the router. As well, if you implement HTTPS, the Ingress Controller and its Certificate Manager companion will manage the certificate requests and their deployment. To create and access a remote service from CF, going from the service broker, so you have two phases. The first phase is the provisioning, where you have to open a firewall to expose the remote service API to the service broker running on your Kubernetes cluster. You have as well to install the remote cloud service broker with a credential. And within Cloud Foundry, you will create a service instance required by your app from the marketplace. After, when you have got access to this service just created, to use it, you have as well to open the firewall to this service and to bind your application to the service as well. You can check all these services through either the Stratos console or the Cloud Foundry CLI. So the high availability is very important in the cloud era, and this is performed by the CAP deployment. And this CAP deployment will rely first on the Kubernetes offers, so meaning if you go to the cloud provider, they will offer you a Kubernetes offer with HA. On the SUSE CAP itself, we have an HA configuration pattern with multiple components replicated, and you will have to request Kubernetes node to be spread among multiple availability zones. As well, SUSE CAP HA placement inherits from that and can make use of this availability zone for the Cloud Foundry components. The network load balancer itself, it sends the traffic to the available routers. On the service side, HA should be done on the selection of a service plan that you can get from the various service brokers. So to synthesize our SUSE CAP components on the various public cloud, here is the table. So first we have the SUSE CAP itself that can be deployed on any of these public cloud through Terraform and Helm. The Stratos console itself will be as well deployed through Helm. The service broker exists for each of these clouds through a specific Amazon, Azure or Google service broker. All of them are deployed as well through Helm charts. The service instances are produced from the AWS Marketplace, Azure Marketplace or GCP Marketplace. In terms of DNS, you may choose between various options between one of these clouds, but every of them can for sure ensure a public DNS service for any of your CAP instances. The cert manager itself is deployed inside your clusters through Helm as well. The ingress controller is also a component of on top of Kubernetes that is deployed through Helm. And for the Kubernetes, it just generally either deployed by the Terraform or by some other means, or even through the portal of various cloud providers. In terms of storage, the storage that is required in some services is provided by the IaaS layer of your cloud, but it's integrated inside the Kubernetes through what is called persistent volumes. So when we have all that deployed, we can use the various CAP deployed on any of these clouds to manage deployment of various applications in multiple languages on top of this Cloud Foundry solution. Your DevOps pipelines can benefit as well of this multiple CAS deployment and can use the CF CLI to interact with the CAP instances. So to terminate, I will resume this. So to conclude, with the SUSE Cloud Application Platform, we have seen that we have no lock-in and you have a choice. You can deploy on any cloud and you can benefit on all the services available to these clouds. I thank you for your attention and see you on the various social networks. Bye-bye.